So the first thing we have to do is what's called your setup. So we have to do a new setup, which starts on the left over here. And it's automatically chosen that that's our model. And this is called our datum. That's like where we're going to measure everything from on the CNC. So you see how Z is up? We're not going to machine it like that. So we have to put in what the work coordinate system is. So if you click on this box point, then you can click on these points and it will move around. We want generally the bottom, because that's the bed of the CNC that we're going to measure from. And we need Z to go up. So if we click here, we can choose the Z axis and the X axis. So that this will be the Z axis. And I can flip the Z axis like that. And I also need to flip the X axis. And then I can press my box point again and put it down there. Because when we're looking at our machine upstairs, the Y is coming at us and the Z is pointing to the left. So every machine could be different. And then if we go to our second tab, the stock tab, we can do a fixed size box. And if we just do relative size box, it will give us the actual size here. So it's 11 by 12.6648. The relative mode always adds stock because they assume you're going to machine every side of it to like square everything up. We don't have to worry about that so much. So we could just use the relative with no additional stock, but we do want to machine this top flat surface to make it perfectly flat. Although you have it probably flat enough, right? Yeah. So we'll just pretend. Yeah, I mean, it's good enough for what you're using, but just because I want to show you one of the operations, we're going to add stock to the top. So if you look closely, it has a little extra material up there. And then we can press OK. So here we have our setup. And then we can choose, first, we'll choose a 2D toolpath. So if you click this, this gives you all the 2D toolpaths. So we're going to use a facing operation, and that's just going to smooth the top out. So if I choose face, it asks me to select a tool. So I have this Alfred Tools database. See if you click on this tool library right here, see if you can see this Alfred Tools in it. So right click anywhere, and you can choose tutorial tools and turn that on. So down here, like you can right click that and turn the library on. And that'll just give you some of the basic tools. I have a tool library that you can import. So if you right click on your local and go import libraries, you need to just download the library from Canvas. So in Canvas, I now have uh I'll put it in there. I don't have it in there yet, but essentially, let me I'll export it, or I'll add it into Canvas right now. So it's here, the tool library, which you can download, and then you'll just on the local tab, you can just go import libraries and find that library from your downloads and open. Sorry, it's on. If you look in the modules and then go down to CNC and CAM, it's at the bottom there.
Can you explain it all again? Sorry. No.
What? You got stuck?
Yeah, but to dig at. Anyway, sorry.
So, basically this week I'm going to be showing you the CNC, and then I think I'll show you the scanner. And those are the last kind of machine demos. Then you'll we'll be going into the software again, and you'll be physically, hopefully, working on the machines. So, and getting ideas for things you want to do. Once you see all that, you'll have kind of an idea of what all the different software does and kind of where you want to what you want to concentrate on. So I will be giving one more, like a drawing assignment for the CNC upstairs, and I'll show you that later. So if you've uploaded your Alfred tools, you can close it out, and then we're going to do that facing operation, and we're going to select a tool, and you're going to go to your Alfred tools, If you don't have those, you can go to tutorial tools, and we're going to use a flat end mill, a 1/2 inch flat end mill, and it doesn't matter how long it is for this operation, but I'm going to choose this 4-inch one. And then then you can press OK and it will save that, and your toolpath tab will show up over here and show you your tool that you've chosen. And if you right click on that or double click, you can edit that toolpath again. And these tabs, this is a tool that we choose, and this is how fast the tool is going to go. We can't control our spindle, so this is going at 150 inches a minute, which is probably too fast for wood, but we'll not worry about that right now. Most of the Alfred tools I have set for cutting foam. So this is our geometry tab. So we have some options of how we choose. So I'm just gonna choose this chain, and that just means like an enclosed lines. And you can also select an open chain, but ours is closed. And then click OK. And if you need to make this, you can make this bigger. Our next tab is called the Heights tab. So what this does is show us how far it's going to retract. What's called the feed height and the bottom height of how far down the tool can go. So that bottom height, it won't go below that. So that's like the safety kind of. So all those are good for us. And then the next tab is called passes. So if our tool is a 1/2 inch thick wide, here's a 1/2 inch end mill. So we're only gonna go over, not all the way. Like, so your step over is like how much each pass it goes over. So this has a setting at 0.35, which we can use that. So we'll use all these settings that are here. If you wanted to, you can change the direction. Like you can have it go like diagonal. And then we don't have to do anything here. And then we just press OK. And then yours will automatically generate the toolpath. But I'm going to go Control G. So that's the toolpath, just going back and forth. And then I can simulate that. And if I turn my model off, it's just going to be taking off material. And your model you can turn back on here. So that's just that first simple toolpath. This is also where if you were just going to like cut something out of plywood or something like that, we could use a contour toolpath and just follow the contours. Our next toolpath, we'll go over here and to the 3D toolpaths. And these are all like, these are both like roughing out, so taking a lot of material. So we'll use a pocket clearing, and we'll keep that same tool. And then our geometry, we're going to use a selection, and we'll select a chain again. So that's going to be our boundary. And then here you can tell it to avoid certain surfaces or not machine certain surfaces. So I'll use a plus and say I don't want to machine that. So here's avoid surface. And then I'll generate that again. So if I simulate that, so you can see, because that's a flat end mill, you get all those, steps essentially. And then I also get a warning because this tool can't get down into a certain area. Um, but that's okay for now. So the final toolpath we would do well, it could be a bunch, but I'm going to use this scallop toolpath, which is pretty good for like undulating surfaces. But you can just go through and kind of guess and then try to select your geometry. Uh, but these are all different strategies. So some are just straight parallel, but the scallop works good. So I have to go and select a different tool, a ball nose end mill, or a ball end mill, not bull nose. Bull nose is when it has a slight radius. It's like flat, but with a slight radius. And you can see all these different types of bits here, which some we'll use and some we don't. We mainly just have flat and ball nose, and then I have some engraving bits and things like that. But so we are going to use our massive 5-inch, half-inch ball end mill, but you can also just if you just have the tutorial tools, I think yeah, it just gives you up to 2.75, which is not long enough. So then again, I have to choose my geometry. So I can choose again a selection here, and I can tell it to keep the tool inside of that boundary, centered on the boundary, or outside. I'm going to say center on the boundary and see what happens. And then if you hover over this, you can see that if that's enabled, on the right, you see how it will use the side of the tool. On the left, it'll just stop when the tip of the tool gets down to the end of the cut. again, I want to avoid this. And so I'll say avoid that. Click OK. So my heights are set all the way to the model bottom. Normally you would select if it will let me. No. I don't have anything to select here, but I might just draw a point there at the bottom of that circle to say like don't go below that. But if I choose this, I can also offset it like 0.5 just so I don't know I'm not going to dig into the table. Then I have my passes. So this has a step over already set 0.02 inches. I'm going to go both ways. And then I'll just keep all this the way it is. Oops. I just have to, now I have to do that again. Uh, I hit OK because then it will save this like here because I just went through the whole thing and hit the wrong button and it disappeared. So that's just a little trick. So I'll use the silhouette tool center on boundary, or not silhouette, selection. Hide this face. And then generate that. And this will take a second longer because it's quite a lot of. There we go. Huh? It's actually the big tool, but then I'll simulate if I just highlight this up here and go simulate. It will simulate all three, and you'll notice down here that there's every color change is a different toolpath, and see all these red marks? Those are bad because our tool's not long enough, and actually this is going to hit because this is the 5-inch one, so it's okay. But if I just click this and say go to end of toolpath, it'll simulate that whole toolpath and then show me where this is gouging out. Um, well, we have to scale this down anyway, so then you can see, that it goes and it takes away more material. And if you go deep in, you can see there's actually there's like a factory in here. You have to get it smoother if you want to see the whole thing. That's how they simulate. They take pictures and like map them on to make it seem like a mirror finish. Yes. Yes. So it can go right up. The center of the tool will go to the center of that line and not past it. Huh? Yeah, see, that's the flathead one, and see how it's taking off more. So this, if we could just go back to our design, uh, this will have to be scaled in Rhino because we want this round, but this is 5.5 inches, so our bit won't fit in. Uh, Probably for the clearance, so we have to check with that tool. I ordered some 5-inch tools, so should be here next week. Yeah, to get over it and down in. Yeah. Unless you took the bed out, like lowered your model down, but that's not that safe. So that is the basics of camming. This is just a vector file. So if I went to the manufacturing space and did a new setup, I can tell it that the stock is a 1/2 inch thick. And then I could do like a 2D contour and choose the contour to select the tool. So within these, I have, you can build your own tools in here also. So I can, the bottom height. I can do a selection and just choose one of these and it will set that bottom height there. But I want to go a little bit in, so I would put a negative. Then I'll generate that. And then if I simulate it, this is generating here. There's so many points that it takes a bit. So that's just if you wanted to draw on the line, but you could tell it if you have circle to cut the inside of the circle out or cut the outside of the circle out, and you can also put tabs in because you can't just have that piece that you cut out like free floating.